Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze the leaf spring for its thermal analysis. Here we are performing the steady state thermal analysis, which means we are going to consider a particular temperature which is going to remain steady at the eye of the leaf spring. So we will start by double clicking on steady state thermal. There are various materials used for the leaf spring. I am going to choose some general materials like aluminum alloy, stainless steel and titanium alloy. Next I'll go to project and update project. Next I'll go to geometry and import the model directly. I'll give you the link for the model so that you can use it for your analysis. Next I'll go to model and double click on it. I'll first go to geometry and change the material to aluminum alloy. Next I'll go to mesh and I'll change the sizing to fine and update. Then I'll go to steady state thermal and insert temperature at the eye of the leaf spring. I'll take the value of temperature as 250 degrees Celsius. Next I'll insert convection over the body. I'll give the film coefficient as 0.0001 watt per mm square degree Celsius because it is exposed to air, so the convection will be air based. Next I'll insert radiation over the body. I'll give the value of emissivity as 0.3. Next I'll go to solution and insert thermal temperature over the entire body. I also want to see the total heat flux over the body. Then I'll insert directional heat flux along the x-axis and I'll insert the directional heat flux along the y-axis. Now I'll go to solution and solve. You can see here, this is the first result obtained of the temperature. You can animate and see the result. The maximum value is 250 and the minimum value obtained is 22.92 degrees Celsius. And there's variation of temperature over the leaf spring as you can see. Next is the total heat flux over the body. The maximum value is 0.62564 in these zones. And this is minimum here, it is 3.056 into 10 raised to minus 5 watt per mm square. For the directional heat flux along the x-axis, you can see the highest value is 0.53934 in these zones and the minimum value is minus 0.54227 as you can see. You can also see the directional heat flux along the y-axis. There is a variation of temperature, the maximum being 0.12843 and the minimum being minus 0.56786 watt per mm square. Along the y-axis, you can see a variation of temperature over the various leaves of the leaf spring. Now we will change the material to stainless steel and we'll solve once again. Actually, stainless steel is not the correct material to be used. You should be using plain carbon steel, but the material properties would be more or less close. That's why I've used stainless steel. Otherwise, you can take out the properties of plain carbon steel and you can add it as a material and use it for the analysis purpose. Now you can see the temperature variation over the body. These variations will be seen between 250 to 22 degrees Celsius. There will be variation of temperature over this body. You can see the total heat flux is now maximum of 0.176 watt per mm square in these zones I of the leaf spring, and it is minimum of 4.849 into 10 raised to minus 11 watt per mm square. You can see the directional heat flux has a maximum value of 0.119 watt per mm square and the minimum value is minus 0.1189 watt per mm square over the body. You can also check the directional heat flux along the y-axis. It is different as compared to the previous one. And lastly, we will change the material to titanium alloy and see what is the result. You can just press the control button and select all of them, and collectively you can change it to titanium alloy and solve once again. Now, titanium alloy is a costly material, so it is not used commonly, but it is also a material which can be used. Now again you can see the temperature variation over the body. The total heat flux, it has changed. It is 0.2 watt per mm square. You can see the directional heat flux along the x-axis is also varied, and along the y-axis also it is different. It is going to be different for different materials. Now based on the temperature variation and the total heat flux over the body, how much heat is lost, the material which will help in losing maximum heat is going to be the best. But you also need to understand that there is a comparison which has to be drawn amongst the material based on cost and functionality. Aluminium alloy, for example, is very lightweight. It is losing more amount of heat, but its life will be less as compared to steel and titanium alloy. So in that case, you may have to go for a better life or a service life of the product. If heat loss is the main aim, then you can go for a product which is giving out more heat in the atmosphere. If weight is the concern, then you can choose accordingly. If cost is the concern, then you can choose accordingly. So based on all these parameters, you should decide which is the best material for your application. It is not specific to a specific object. For example, the leaf spring will not be made only of steel. It can be made of various other materials. Now in this, one more aspect is of the composite materials which are being used for the leaf spring. In fact, the leaves can be made of different composite materials also. For example, epoxy carbon, you can have glass fibers. So these are the materials which are also used in these cases so that the heat loss is more, it is light in weight, it is going to have good life with the use of composite material. So you can just change the material over here. You can add a composite material and you can see what is the life of this product. For that, you just have to select these materials and you want to change it. So just go to new material, go to engineering data sources, and here in composite materials you will find various materials from here. So suppose if I use epoxy S glass, or you can use epoxy carbon. Now you can see here it is asking for isotropic thermal conductivity. You need to give the value of isotropic thermal conductivity for epoxy carbon. The value is 2.83. So you can just add this property, go to project, update project. Here you can now change the material to epoxy carbon for all of these. You can see it has got changed. You can go to solution and solve once again. So here you can see the temperature variation over the leaf spring. You can see the total heat flux is 0.093 over the body. Then you have the directional heat flux of 0.082 watt per m square maximum along the x-axis. Along the y-axis also you can see the 0.0846. So epoxy carbon is also one of the material which is used for these purposes. So you can accordingly analyze and decide which is the best material for your application. So with this, I end the session. I hope you have understood the analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.